Hello, 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 everybody, and welcome back. We're still looking at the 2007 Fermat paper. That's the grade 11 multiple choice contest. I'll remind you, if you'd like a copy of this contest, to click the very first link in the description. We're looking at question number 22 right now. Last video we did is we started off part C with question 21. Now we're on the second of the sort of 5 hardest questions. Let's take a look at question 22. A ball is placed at point P on a rectangular billiard table. A ball placed at point P on a rectangular billiard table is shot at an angle of 45 degrees to the edge of the table. So based on the arrows in the picture, I'm guessing we got 45 degrees here. Okay. After successively bouncing off the edges of the table at 45 degree angles, it returns to point P as shown. If the ball travels 7 meters, the perimeter in meters of the table is closest to... interesting. The perimeter of the table. Okay. So, we know the ball travels 7 meters, and we know exactly what the path looks like, and we know that basically all these angles in here are going to be 45 degrees. Let's draw this picture and see what we can calculate. We got point P here. Bounce, 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 and then it's back. Okay. So I'm going to use a blue dot so I don't have to keep writing 45, but this is going to be 45. So the angle at which it hits is 45 because parallel sides of a rectangular pool table. Angle of incidence equals angle of reflection. Angle of incidence, angle reflection. We're going to get a whole bunch of 45s. Now, it's also a rectangle, so we get some right angles in the corners. But also note that we got triangles here. 45, 45. This forces this angle here to be a right angle. All of these are going to be right angles. So we've got some rectangles here too. You know, it was sort of clear from the picture that these were rectangles, but you have to make sure. You got to know. Okay. Now, in terms of the perimeter, because that is what we want to talk about, I know this length is equal to this length, just because we've got isosceles triangles here. That's the idea. And these lengths here. And these ones here. And I also know things like, I've never had to do 5. No, that's 6, but whatever. 2, 3, 4, 5, 6. But 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5. Because they're opposite in rectangles, they must be the same length. But then, it's isosceles. So these are the same. And opposite in a rectangle, these are the same. Okay. So, let's give some names to these things in the rectangles. I'm going to call this A and this B. Well, then this is A, this is B, this is B, this is B, this is A, this is A. And we can make some calculations. For example, I know that if these are A and it's this one in here is a right angle triangle. By Pythagoras, I can say this is root 2a. Similarly, down here, this is root 2b. And all of this is coming from the sort of two observations. If you got x, your hypotenuse is root 2x. And we can go the flip side. If you know it's all because of this 45 degree stuff that we have isosceles triangle. So if you have an isosceles right angle triangle and your hypotenuse is y, the legs are y over root 2. Okay? So that's how I get root 2a and root 2b, but now I can also reverse it. We get a over root 2 here, a over root 2 here, b over root 2, b over root 2, b over root 2, b over root 2, a over root 2, and a over root 2. And this gives me enough information to calculate the perimeter in terms of a and b. Now, is this going to get me my final answer? Not without a little bit more work, because I don't know what a and b are. But you'll notice that the a's and the b's perfectly let me describe the length of the path that our billiard ball travels. And we know that that adds up to 7. So that might be helpful. Okay. So what do we have? So perimeter, the thing that we want, the thing that we care about, is we've got a root 2a plus 2 root 2a's here, or 2a over root 2's, plus another 2a over root 2's. Okay. And then we have, and I'll cross these off as we do them. And then we have root 2b plus 2 copies of b over root 2 plus 2 more copies of b over root 2. Now, 2 over root 2, that's just root 2. Okay, so really I've got 3 root 2a's plus 3 root 2b's, or 3 root 2a plus b. So that's the perimeter. If only I knew a plus b. But remember, and I don't want to flip the page, so because then I'd have to sort of redraw the picture, so we'll just erase our observations from before. Notice that the ball travels. We're told it's a total of 7 meters, but, and we'll get another color out here, how about the orange? Ball starts at P, it travels B, then it travels a length A after that, then it bounces and travels a length B, then A, then B, then keeps going for a distance of A, then B, then it bounces A, and now it's back. So, we travel B plus A plus B plus A plus B plus A plus B plus A, and that's really 4A plus B. Now, I have no idea what A and B individually are, but I don't need to. I just need to know A plus B. A plus B is 7 over 4. So we want 3 root 2, 7 over 4. Or I guess you could say 21 over 4 root 2. But they don't give us those possibilities. We've got a closest to. And that's where we grab our calculator. So we had 21 divided by 4. And we're going to multiply that by root 2. And I get 7.4246 approximately. Now the question's asking me closest to. Well, the 7.4 sort of tells me it's going to have to be B, 7.5. So our answer will be B, closest to 7.5. Not bad at all. And that wraps up question number 22. And in the next video, we'll be looking at question number 23. I'll see you guys there.